Thank you. Yeah, today I'll talk about container security. Last year I had a similar talk. Was anyone here last year that was listening to me? Okay. Okay, great. Okay, let's start. First of all, who am I? I'm Brelih Aleš. First, I'm a proud parent to my 1.5-year-old daughter, even though she's gaining some attitude and commanding me all the time. But yeah, that's the part of it. Basically, now I have 2 women commanding me in my apartment. I'm also a security engineer at 3FS, but I come with a developer background, full stack, also some DevOps, also some cloud. So yeah. I've also been part of LogShield. Now it will be the 4th time, I think. Just recently, I got my first security certification, OSCP+. The plus means that you need to renew every 3 years, so they figured out they can get more money out of that, so okay. And yeah, this is my contact. You can also find me GitHub, LinkedIn. And also, yeah, as you will see, these whole slides, you can get them here. If you want to, you can follow it. They have some demos inside of it. It's hosted on my domain, and I also have some blog with some security titles, I guess, posts. Okay. Okay, previous year, I realized that I just straight went a bit deep into the whole container business, as I was exploring with kernel API from Linux, and I figured out that maybe this is not the best way to go to, right? So for this year, I thought to myself that it would be best to start with some basics, get everyone on board what containers are, then move a bit deeper into the whole kernel thingies from Linux, and end with some container security. Fair warning, I'm not such a smooth talker as the presenter before, so bear with me. Yeah. Okay, so what even is a container? Basically just some lightweight portable software package that we can run it anywhere, right? This is really great part because for us that we are a bit older, we are used that, for example, I was at a company where, for example, I was developing on PHP 5.6, production was PHP 5.4, right? And okay, that didn't have a lot of issues between that, but once I developed the thing and published to a client, was running on PHP 5.2, and I was using traits which weren't introduced back then, so everything crashed, right? So Docker really helped us with that because basically their motto is build it once, run it anywhere, right? Because it just packages everything it needs for a process to run. So from libraries, dependencies, whatever. Now, what are the properties? It's isolation. So this is great also from security perspective because process inside of a container isn't really aware of any other processes running on the host. Also encapsulation, which is the part of build it once, run it anywhere. So it means that it will contain all of the libraries, all of the packages it needs to run inside of that box. And then you just transfer it and you run it, right? What's also great that we can also restrict some resources that our process can use, right? Well, there are other ways to do this without container, but yeah, this also allows us. Why is this good? Because we can restrict just a part of CPU, so when it reaches that part of CPU, it will crash, and then the container orchestrator will just respond that container, or even we can even restrict how many processes it can spawn inside of a container. So this basically can prevent fork bonks, for example, right? And other things. So yeah, what are even the benefits? Why are we using it? So, quick question: how many of you have used container Dockers before? Okay, so basically all of you. Okay, great. So, sorry for the quick refresher course. So yeah, benefits are portability. As I said, build it once, run it anywhere, so we can just take it with us and run with it, right? It's lightweight. Because before the containers there were VMs, there still are VMs, but VM is a bit heavier, as we'll see. What's also great about containers that it allows easy scalability. So there's a principle in IT that says it's either a pet or a kettle, right? You pet the pet, you feed the pet, you name the pet, right? But for the kettle, you don't really name it, right? And the kettle is like, I need one more, I'll buy it. I have too many, I will just send it to the happy place, right? And the containers are like a kettle, right? Because we can just spawn another one because they're lightweight, or if you don't have traffic, we can just kill it, right? And usually we don't do this manually, at least I hope, and we use some container orchestration. Containers also allow faster deployments. So why is that? Well, usually on production where container runtime runs, then we are running a certain version of container, Docker image, right? And then when we want to run a next version, we just say, hey, use that new version, and then we'll just pull the image and run it, right? And also what's great about containers, it provides an extra security, right? Because of isolation part and etc., as we will see. So yeah, containers and virtual machines are quite similar in what they want to achieve, right? They want to create a self-contained unit that we can just use to run something, right? And we want to avoid physical hardware, right? But there's a main difference that's also important from the security aspect, is that containers share host kernel, while VMs, each VM has its own host, right? So its own host kernel. So what does it even mean, right? It turns out when we run application, it runs in user space, right? And then when we want to read a file or just allocate memory, we cannot do that. We need to ask kernel to do that, right? And we use system calls to do that, right? So the libraries you're using in your C#, Java, Go, whatever, it just uses system calls under the hood, right? And because of that, we need to keep it in mind that containers all share the same host, right? They will, when you're using system calls, they will use the same host underneath. Well, not all, but let's keep for now simple. So this is how it looks like, really simple. I mean, on the left, there's VM, which has infrastructure, some hypervisor, and then it spawns multiple OSs. And then on top of that, you have applications. And for the containers, it's one OS. Then you have a container runtime, which in most cases is just Docker engine that we use locally. And then the container runtime handles of spawning containers and doing whatever with them. So yeah, building blocks. I know you said you already know containers, but still, let's just move fast through. We have images, basically the templates to run a container. And we package everything inside of it, and then when we want to run a container, we just say docker run that image and which command to run. We can also tell by default which command to run inside of the image, but okay. Then we have containers, which are just running instances of these Docker images. Then we have Dockerfile. Basically, Dockerfile is just a set of text instructions how to build an image. There are other ways to build an image, as we'll see, but Dockerfile is the best because it's a declarative way. Because once you work in IT, you might gain some money, right? But you will steadily lose your sanity, right? And if you want to keep your sanity, please try to stick to the declarative approach, right? So, like infrastructure as a code, etc., right? Because else, yeah, good luck. Yeah. Now, then we have volumes. Volumes are just a way, because it's a kettle, we can just kill it, right? Volumes is a way to persist data across multiple containers. Because usually if you have an application, you are working with data, right? And then data, you somehow need to store that data well, right? The next thing is the Docker, right? So when you type the Docker run Docker PS, that's a Docker CLI, right? This doesn't do anything unless you're running Docker in a rootless mode, but I won't talk about that. Basically what it does, the Docker CLI, it just talks to Docker daemon. Docker daemon listens usually on a sock, at var run sock, Docker sock, or it can talk to it using a port, right? And then the Docker daemon does all the heavy lifting. And lastly, because images are portable, we need somehow to publish that image somewhere so we can pull it, right? So this is where the Docker registry comes into. Okay, so Dockerfile, really simple. You start with some base image, so from Python, whatever. Then you use workdir, for example, to set working directory for the process when building the image, in this case, /app. Then you just copy everything from the local, from the host to the image. So this is what copy is used, or add, as we'll see. Then we run commands. what we want to do, and we specify which command is run when running that image without arguments. Okay, so a bit more about Docker image. I'll get a bit deeper into this later on. Basically, Docker image is just a lightweight standalone executable package, as I said, that holds everything inside of that package, so we can just run it and everything works, right? Usually. Now there are multiple platforms, you have to rebuild for certain platforms, certain packages don't work on certain platforms, so let's just be naive and let's say it runs everywhere. Now properties about Docker images are the images are immutable. So we need immutability because we want reproducibility, right? So whenever we run a container from that image with same arguments, we want the same container to be run, right? But also we need to be careful with tagging and versioning, and I'll talk about this again later. We need to keep in mind that the Docker image has a layered structure, right? Now, why does it have it? Because this way it's more optimized for your hard drive, so it wouldn't hog all of your hard drive. How it does, later on. And yeah, it allows versioning and tagging. Docker registries, as I said, way to store images. Most popular is the Docker Hub. You can also use from AWS, Azure, GitHub, GitLab, whatever, you name it. Yeah, and they can be public for everyone to download it, or you can have private ones. So you need to somehow authenticate to the Docker login something, right, and then use it. Okay, now as I said, the Docker CLI just talks to the Docker daemon, and Docker daemon usually listens on the socket, which is var run docker sock. This is the default, but you can also set it to listen on TCP ports. Why is this useful? For example, if you want to connect to a remote Docker engine, right? So your Docker CLI talks to the remote Docker engine, which is located somewhere where you have production, whatever. And for Windows, it listens at some named pipe. Okay, I'll just, as I said, as I saw, you're already using containers, so basically I'll just skip this thing. This is how you run containers, Docker run, interactive to gain the persistent IOE stream, and TTY for pretty colors. Then image, and then command, right? You're mounting volumes with volume and publishing ports, because once you run a container, this container is creating its own network stack. So basically, even though you're running Nginx inside of a container that listens on a port 80, you can't really access it. Right? Well, you can, but the IP is changing, so next time you will be running containers, it will fail to connect to that IP, because yeah, the way how routing works, etc. Other useful commands is ps to list them, -a to list also the stopped ones, remove, stop, logs, image. Okay, let's jump a bit deeper. So now we know some basics. Now I'll focus on Linux, what? Yeah, Linux, I guess, implementation. So in Linux, container is just a process. So whenever you're running Docker run something, that's just a process that will spawn on your machine. If you check ps aux, you will see that container as one of their processes. Basically, to be more exact, in Linux, a container is isolated and strict environment that you can run multiple processes inside of it. So, as I said, containers are isolated, encapsulated, and we can restrict resources. So, how does Linux do this to make a process a container? We'll check it out. So, first of things, it uses a kernel feature called namespaces to provide isolation. Namespace allows us to have our own isolated global resource, instance of global resource. So what's that? For example, there's a PID namespace, which allows us to isolate processes process inside of a container can see, right? So because if you're running containers, you don't really want to see which processes are running on host, right? Because if you see that, potentially if an attacker gets access to your container, can enumerate your processes and find additional attack vectors, right? So basically you want to do that. And their namespaces are the things that allow us to do this, right? Because they provide some kind of isolation. An important thing also is that changes to that isolated copy of that global resource is only seen inside of the process of that namespace, not to the outside. So for example, if I create a new namespace, a UTS namespace, which basically handles hostname, and I change hostname inside of a container, this won't really affect hostname on the host, right? This is why also every container has its own hostname, right, when you run the container. This is the API you can use in Linux. Use just unshare, and for example, this is I want to create a new process ID namespace, so dash dash PID, dash dash fork because it's needed for the PID namespace, and because if you do just those two, it will work half and a half, let's say. What will happen? Your process inside of that namespace will have process ID 1. Which is okay, because we restarted the process, because process ID1 is systemd usually, right? But problem is, if you will use ps-ox, right, you will still see all the processes from the host, right? Because ps, how it works, is just read/proc, which is pseudo file system for the status of kernel, right? And because we are still using the proc from the root, it will be able to see the processes outside. So to overcome that, we can use the mount proc flag, which means create a new mount namespace and remount the proc pseudo file system. And that will work also if you want to try. There are different types of namespaces. We have control groups, IPC, network, mount, process ID, time, user, UTS. This is how it looks like usually. I mean, it looks like I just created this way just to say each process needs to be in one namespace of a type, right? So why is this the first time we're hearing about that, right? Turns out that systemd, when ran, it's placed in some namespaces by default, and every time you fork a process from that, right, it gets placed in the parent namespaces, right? Unless we are using unshare command, right? And this means create me a new namespace for that. Else it will just take the parent one. Okay. So the next part is encapsulation. So this is probably when you're thinking, okay, this is Docker images. So I'll try to explain how Docker images work a bit more and why we need to be careful with it. So yeah, there's an API called change root, and basically what this means, change root to that folder, tmp root, and run some command inside of it. And that command won't be aware of the host root, but it will think that tmp root is the root of that process, right? So that is where it will search for commands, whatever, right? Which makes sense, right? So if I put this into picture, I create a new root, and then I go change root to this folder, and the process will only see the blue square, and it won't be aware that even the gray square exists. Okay, so a bit more about Docker images before I've shown a simple Docker image, but let's go a bit deeper. So what really happens under the hood? Where are the layers? So what Docker does, when it's building an image, okay, I will not spoil, what it does, it goes line by line, right? And what it does, it starts with from, and it unpackages that base image. And because this unpackaging changed your file system on the host, it means I'll create a new layer. This is the layer 1, which just node alpine. Then it goes to the next line, goes workdir/app, and this didn't do any changes in the file system, so it won't create a layer. Next thing, it will copy package.json. This created a change on your file system. Let's create a new layer. And last is run npm install. This after 2,000 years, it will install node modules, and this will create a new file system change, right? And this will be the last layer, right? So this is how layering works. And this should be mutable, right? Because we want containers to be the same if you're using the same image. So how can we write in a container, right? Because if I spawn a container, I can write inside of it. Well, what Docker does, it just places additional layer on the top, and it's writable. So basically, you can write on it, and you won't affect the base image. That is also why you can use Docker commit, I think it's called, that you can create an image out of a running container, right? What it does, it just creates the top layer as a mutable and names that image. Okay. But we need to keep in mind that these layers are independent. They do not belong to any image. You've just created a layer, right? Why is that? Well, for example, if they weren't independent, first of all, why even layers? Let's imagine we have 5 node JS apps, different apps, and if we wouldn't use layers, it would mean that each of that app would have to be a whole chunk of stuff. And this whole chunk of the stuff is also a copy of Node.js and base image that Node.js is basing on, right? So that would mean that would be a lot of storage used on your local machine and when you push to the cloud. And then you have to pay Bezos a lot of money, right? So they wanted to avoid that, right? And then what they did, they used layers. So each layer is independent. So the next time I will be using a Node.js app, right? This is Node.js, right? It will just see, oh, I already have this layer 1. Let me borrow it, right? Oh, I already have that. Let me borrow it. And then it will create a new image, probably with just one layer, different layer, because that would be the application code. But if they're independent, we need somehow to link them together. So this is where the manifest.json comes into the play. And in manifest.json, whenever you pull an image, you first pull the manifest.json, right? And inside of this manifest.json, there is Docker image name. And there's a lot of stuff, but also one property which is called layers. And these layers, it tells your Docker client which layers to pull from the registry. So that is why when you go Docker pull something, the downloading executes in parallel, right? Because nothing is dependent on anything when using layers. But now, for the change root, basically, to work, we still need some kind of a file system, right? So how does Docker do that? Well, it uses, this is too many stuff on my ears. How it does that? It uses overlay fs to mount that layers together, squash them, add additional writing directory on top of it, and mount it somewhere, right? This is first what's done, and then it uses change root to that mounted file system. Okay, for the last part, it's not the last, but yeah, the next part is resource restriction because we want to limit, as I said, CPU, how many processes spawn, memory, network, whatever, right? And for this, the Linux uses control groups. And this is a way for you basically create some kind of groups, and then you say this group can only use such and such amount of process, network, whatever. You can check out the C groups with that command systemd-control group ls, right? And for example, if you're using, when you're running container, whenever you run a container, you get some hash, right? Then the identification of a container. Now, the naming convention that they took at the Docker to name their control groups is docker-that hash.scope. So if you run a container, you can just check its control groups using system control show docker dash your hash.scope. And yeah, nothing much to say about it. This is just an example. For example, the blue C group can just use a chunk of CPU, a chunk of storage, and S is unlimited. Okay, we have additional features for isolation that are given to us that we can use. And these are seccomps and AppArmor SA Linux, which is mandatory access control, I think. So what seccomp is? Well, seccomp allows us to filter which system calls your container can use, right? Because, as I said, all the containers will use the same host. So if it uses the same host, basically we are scared for other containers, right? Because they could potentially escape that container, as we'll see. So using seccomp profile, we can basically say, hey, only these system calls can be used from this container, which is kind of good. It gives additional defense mechanism, right? So how can you get a seccomp profile? Well, there are tools, as always, but most recently there's a technology called eBPF, and this eBPF can basically just check your process and see which system calls it uses, and you can use that information to create a profile and just apply it. And there's also mandatory access controls that, by default, I forgot to mention, there is a default seccomp profile and also default AppArmor SA Linux profile loaded by Docker. Yeah, and yeah, this Mac just provide mandatory access control to restrict container access to resources, just additional security thing. So let's put everything together. What makes a container, right? If we get a bit deeper, we have some infrastructure, container runtime that uses namespaces to isolate C groups, to restrict resources, seccomp roles, to restrict system calls, SA Linux or AppArmor to restrict access to some resources, and then we have some application running on top of that. Now, I was talking about Docker daemon, right? But it turns out the Docker daemon is not just one process that's running, right? Docker daemon, basically, when we use Docker CLI, so that pretty Docker PS stuff, we're talking with Docker daemon that exposes API, REST API, a Docker sock, or some ports, right? And then this Docker daemon it's not responsible for actually creating containers, but it's more responsible for authentication, for keeping track of volumes, keeping track of network, etc. Right? What Docker daemon does, it communicates with containerd. Containerd was part of Docker daemon, but was then split out because they wanted to focus just on the container runtime, not the whole process, right? Because if you have something inside of it, I mean, in one repo, it quickly tangles up, right? So they split up. And yeah, Docker daemon communicates with containerd. This is done using gRPC. And then containerd is actually responsible for starting containers, stopping containers, pulling images, deleting images, whatever. Basically, it's the low-level container runtime, while the Docker daemon is high-level. Now, under the containerd, there is a thing called containerd shim. So what is this used for? Well, for example, not sure if you know, you can spin up container in a live mode. I forgot the property, and this means that your container will live even though even if you restart your Docker daemon or containerd, right? And the shim allows us to separate the container that will be run from the actual containerd, so the containerd can be restarted. What it also does is it checks status of the container, and if it's stopped, whatever, it will talk back to the containerd to respawn it, right? Also, it will listen to all I/O streams, so standard out, standard def, whatever, and that's all. And on the lowest part, we have, by default, a runC. What is a runC? runC is just a CLI tool. It's OCI compliant, I mean, OCI compliant runtime. What this means is that it does know how to handle OCI bundle. OCI bundle is just some bundle in which you specify file system and properties for that container, like some base properties like image, whatever, version, not sure what, ports, whatever. And then you have also system-specific properties. Like for Linux, there will be also properties like which namespaces to spawn, which control groups, right? And runC is just OCI implementation that knows how to use that bundle that containerd prepares and run it. That's all what it does. You also have different type of implementations of OCI implementations, like crun, this is written in Go, that it's written in Rust, so yeah, it must be better, right? Yeah, just joking. But also, now we know that containers are using the host kernel, right? So how does Google, for example, manage with serverless or AWS? Aren't they scared that some Russian hacker will use that container that they spawn and access other containers and access some sensitive data? Well, there are other implementations of CI. And for example, Google uses gvisor. And gvisor, what it does, basically, between that process and your kernel host, it will create a user-spaced version of kernel. So basically, your container will talk with the emulated kernel, and this one will filter all the stuff, and then will talk to the kernel below. What the AWS does is they use Firecracker, which basically it means that for serverless, each time you spawn a container, it spawns a small micro virtual machine, right? And that is why the serverless is still secure, even though we know that it should use kernel host. And yeah, and then for Linux containers, runC just uses Linux kernel features like I showed before, unshare, change root, etc., to spawn a container. So at the bottom, it just uses those API. Fun fact, we think that images are needed to run a container, but it's the other way around. You don't really need an image to run a container, but you need a container to create an image. So why is that? For example, imagine you are on some Debian system, and you create from Rocky Linux, right? Run yum install, whatever. How can you actually run yum install on your Ubuntu, right? You cannot. That's why when you're building an image, what it's done under the hood, it spawns a new container, and then inside of that container, it runs each of the command inside of the Docker file. And then when it's changed, it gets persisted. Yeah, this also comes really into the play if any of you is in the CI/CD management, because in your CI/CD, basically, you want to build containers in your CI/CD. But how can I build containers in your CI/CD? Well, the first way of doing that was called. I'll pause and I'll return to this later on when we are on the security part. So, yeah, just keep it in mind. To test this, that I'm not lying, you can just create a Docker file, create an image from, and then run sleep whatever. And when it's sleeping, when building, you can just check Docker PS, and you'll see that you have a container running that's building that image. And also, this is why we can just commit any running container to create a new image. OK, now finally to the topic that you're interested more, container security. I'll split this topic into two topics. The first one is container security from a defensive approach. So how can we make it more secure? And the second one is more from the offensive side, how to break things, right? So what we need to keep in mind first is that containers run as root by default. Before we were thinking, OK, it's running as root, right? You go by default, if you go docker run -it ubuntu/bin bash, and you check who am I or ID, you'll see your root. But before you thought, oh, but that's root in a container. Doesn't make really sense, right? I don't care, right? But now we know they're just processes on your host. So basically, root inside the container is root on the host. Not one-to-one, as you'll see, but keep it in mind. That means that if you mount any file inside of the container, we can change it because we are root, right? And yeah, if you have access to Docker daemon, so if you are in Docker group, you are basically root. So whenever next time you're doing some exercise in faculty that you can use Docker, basically you are root on that system. Why is that? Well, simply, what can I do? I can just go docker run. I will mount root file system from the host to tmp root, and when it's spawned, right? You are root with access to root file system. What can I do? I can just change etc password and change my user ID from 1000 to 0 and say, next time I log in, I'm root, right? So keep that in mind, not trying to teach you how to break things, just be careful when running containers as root. OK, so in terms of defensive approach, we have two things that we need to take care of. First thing is we need to make our images hardened, right? And the next thing is we want to run our containers without some stupid stuff, right? So how can we make our images better? Well, first of all, it's best to use minimal and trusted base images, right? Bitnami is a good provider for these images, for example. Also, what means minimal? Do not install tools inside of your container that you don't really need. For example, if you have bin bash, right? Bin bash can be used to spawn a reverse shell, no problem, right? So why even put a bin bash inside of a container if shell is good enough, if you are running some Python, whatever. Ideally, you would just build something that spits out a binary, and you just place that in some distro-less image, right? And just whatever it doesn't even have shell, and just run that binary. Next stuff, then you can ask me, how can I build a binary if I don't have tools to build a binary, right? And here is where the multi-stage builds come in. You can basically split your Docker file into multiple steps, right? Here, the first step is using Golang image, and I name it as build. Then I build this with copy main somewhere, then run build. And then the next stage is the scratch, means doesn't have anything installed. And what I do, I copy from build, this means previous stage, and place it somewhere. And in the final image, there will be only this, right, the scratch image. First of all, it'll be lightweight, so it's easy to spawn it. And it will be more secure because even if they get access to your code, they cannot run anything, right? Next, prefer copy over add. Why is that? Because with programs, it's not a problem what they do, right? It's a problem what they can do more than just that, right? What we are not aware of what they can do, right? That's the problem with programs. Copy, we know it can just copy files from your host to the image. Add, it can also download links, extract stuff, whatever, right? So just try to avoid that. To prevent any secrets getting inside the image, we can use docker ignore, works like git ignore, which is to say, don't ever push that to the container image. We also want to minimize layers. So, what does that mean? For example, this is a bad approach, right? There are two reasons why this is a bad approach. First of all, when I'm installing dependencies, I'm using update, then next run is install something, run is install something, install something. As we know, each run that changes file system will create a new layer, right? So there are multiple layers. At the end, I'm removing cache. But it turns out that this line doesn't actually make image smaller, but it makes bigger, because layers are already there. But this run layer will create additional layer that will tell to the overlay FS that it should delete those files. They're basically not making this smaller, but bigger. The second bad practice is, for example, if you're mounting some secret, you can copy secret somewhere, right? And then use it. I just piped it to dev null, and then remove it, because we don't want to expose it. But now I know there are layers. So the secret will persist in that image, even though we deleted it, because any image that is available on the Docker Hub, I can pull it, right? We can always pull the image, but then I can also use Docker save output image.tar, and it will create an archive with all of the layers. So I can just check for a layer that contains that secret and extract it, right? So keep that in mind. What you're doing here, basically, you did nothing, right? Even though you try to clean stuff after. How would be a better approach for this? We just install everything in one line, right? And also remove cache. This will actually make cache not appear inside the Docker image. And for the same for the secret, we do everything in one line. So when we remove that secret in that line, it will not persist, right? Because layer will be created after that command is being run, right? So secret is not there anymore. Yeah, also, if you have CI/CD process, it's great to have some continuous security scanning, but also on live environment, right? Because if you're using Docker run something and image is not vulnerable, it doesn't mean that tomorrow it won't be vulnerable, right? You need to keep track. Also, image signing is great to prevent any man-in-the-middle attacks, right? Or some poisoning of your registry. So what this means is when you create an image, you sign it with some certificate, and then you have option to just run images that are trusted. So basically means that match that public certificate. And as I said, if someone comes in and overrides your image, it won't be run, right? What you also need, I mention? Okay. What I also want to mention, don't use image tags to run your containers, right? Like my image :1, version 1, right? Why not? Because this can be overwritten, right? You can use that. And then we had this problem at our company from a big image. Basically, we're using Nginx and privileged image, right? And one day, just everything stopped working, and we're using the same tag. We had no idea. Basically, what it turned out, that when we were using it in containers, we set up run is a non-root user. What that does is just checks that UID is not 0, but the maintainer of the image just changed that it uses user Nginx, right? And that basically did nothing, but it broke our CI/CD. And we didn't update the tag. We didn't do anything. They just published a tag over it. So how can we avoid that? Use Docker digests, right? Digest is just a hash value of manifest.json that we know that links layers together. So if you were using that before, we wouldn't get to that problem, right? Because the new image wouldn't get pulled. And all the dependabot, renovate-bot, whatever, all can work with Docker digests. So it's not really a problem from that. And you can also use Docker image, version 1 at digest. So you still know which version it is, but it won't really be used when creating containers. Okay, now from the running containers, as I said, run as non-root user. That's the most important one. Next thing, don't run as privileged. What privileged is, as I said, Docker, root inside a container is root on host, but it's not really exactly, because there's also a thing called capabilities inside Linux, right? And these capabilities can a bit fine-grain what can you do on the system, right? And by default, when you're running a container, Docker decided that it will only give you certain capabilities, right? And with these capabilities, you should not be able to escape that container, right? But if you use privileged, you say, hey, container, hey, Docker, I know my shit, right? Just give him everything, right? So next time you see a privileged flag on GitHub from a tool you want to use, ask yourself, do I trust this program that has full access to my computer, right? Full root access to my computer. These tools will be mostly, well, I'll try to think of an example when, to be honest, I don't really see when you should need privilege, unless you are really going to a wrong way, right? And you're searching for results on the second page of Google, or on the fourth prompt of ChatGPT, right? But usually you don't need privilege. Because with privilege, you get all the capabilities. What does this mean? I will show later on with example how to escape, right? It turns out, we had a project with 24 containers or so, maybe more. We could drop all the capabilities altogether. We have a command to cap drop, and we can just drop everything. Which capability you usually need? It's just netadmin. Netadmin allows you to bind to ports that are under 1,000, right? But you can overcome that if you just say, hey, my app listens to 8,000, and then you tell to the reverse proxy, hey, if you go to that URL, go to the application that is at 8,000, right? Use seccomp, use Mac. Use read-only file system. Container should not be able to change anything inside the container, right? If you want to change because your application depends on it, whoa, sorry. It works fast. If you want to change it, just mount a volume inside of it, writable volume. Kubernetes has mtdir directive, I think it's mtdir called. You can use the same in the Docker, whatever. Just go it that way. Try to use rootless containers. What is a rootless container? I didn't mention because I don't really have time. Basically, the normal Docker needs to have root, right? Docker engine needs to run as root because to run unshare those API calls, you need to be root to run those stuff. But then the rootless containers came into play, and what that does is that besides unsharing, it also unshares inside of a new user namespace. So what this means, that even a container inside, even if you have a root container using a rootless mode, that UID won't map to root on the host, but it will map to UID of your user that ran that command, right? Also use network segmentation, and yeah, okay, this is what I was talking before, the pin images using digests. Okay, now, final part, container breakout. What is a container breakout? Well, as I said, containers should be isolated, should not be accessed to the host. But container breakouts means that adversaries, or how is that, they escape from the container to the host, which can cause problems. Why? Because, for example, once you get to the host, you can, for example, list all the environment variables for all containers, right? Because you can just go like cat proc asterisk / environ, right? And we'll just all the environments are there. Maybe some API kills, whatever, right? You can also access file system, right? Basically, once you're on host, you can reach any container. So yeah, privileged container. Hope you can see this, else I'll try to, doesn't work. Else I can give you again the QR code, but I'll try to explain, well, too much talking. Yeah, Docker run IT privileged alpine sh. Let's just pretend that enemy attacker got access to our container this way, right? He got shell inside of our container. So our container is privileged. How can you check that it's even privileged? I think it's, if you go to the /proc, 1, because 1 is the process that, the starting process of a container, right? /status, inside you have cap FF. Sorry, capabilities effective. And you decode that, and if you see there's a lot of stuff, you probably need a privileged container. But you don't really need privilege, you just need certain capabilities, right? So what can I do? Well, I can check mounts. I see that etc resolve is mounted from the device. I can just imagine that that's the root hard drive. What can I do? Well, using a privileged container, I'm also host admin. Well, I can just mount the device to a certain folder, right, and access the host file system. What can I do there? Well, I can change etc path, or I can create a cron job, I can change a boot script, whatever, right? So yeah. Next thing is mounted Docker sock. Now this mounted Docker sock usually has its own place, right? For example, if you will try to use some application that gives you some insights in monitoring of containers or some fancy dashboard because you don't love the Docker PS, right? Docker top, right? It will usually tell you to mount Docker sock, right? And also, this was used first time, I mean, at the beginning of CI/CD Docker building process, right? Because basically, we're using containers to build a container. So how can you build a container inside of a container? What you can do, you can just mount the host Docker sock, which is communication to the host daemon, to the container inside, and then the container inside will use the Docker file inside of a container to build image on the host, which is kind of weird if you think about it, but that's the way it works, right? Or don't even need to mount it, you can just expose that port, right? What can I do with that? Well, it turns out if you have Docker sock is mounted, you can talk to the Docker engine, right? What can I do with that? Well, I can just install Docker CLI, right? And then to escape it, I can just run a new container and say Docker run. I want interactive, privileged, because as we said, the privilege you don't want to give. What I also want to do is I want to share process ID with host. So it will not create a new process ID namespace, but it will host one. That will allow me to see all of the processes on the host, right? Then I will disable all the security controls from AppArmor, right? Because even though if you escape, you still can't access certain files, right? Because MacArmor won't allow you. And then I'll just mount the root from the host, because if a Docker sock, we are talking to the host. We need to put perspective that we are on the host. So I'm mounting root to some folder inside the container, using some image, and then I could here just run shell, but because I'm lazy, that means if I run just shell, I would have to cd to that folder, and now I know how Docker actually works under the hood. I can just use change root to the mounted folder and spawn shell. And basically, I'm root on host, right? But you probably think, if I get to a container, I cannot really use Docker CLI because I cannot really install this is bullshit, right? Well, it turns out that Docker sock, as I said, is just REST API, right? What can you do with REST? Well, we can communicate with it, right? So enough, it's to just have some kernel, right? I always say it's a REST API. This time I took some time. I also actually created API calls that would allow me to execute arbitrary commands, right? Nothing really special. You just curl, use Unix socket, and then you have specification that you can use to basically create a container, run container here, prepare command to be executed. In this case, I just listed files, get command ID, and execute command, and this will give me the results of a command. So basically, you don't really need Docker CLI to communicate the Docker engine, but simple API is what you need. Also, I said privileged is dangerous, but it's not just privilege, because privilege just gives additional capabilities. If you see just added one capability like that, that's dangerous, because sysadmin allows me what I did before, right? So mount the hard drive, I mean the device, right? Then if I have sysmodule, I can basically just load a new kernel module into the kernel, and because we know that containers use host kernel, it will load in the host kernel, right? Or ptrace, what ptrace allows us to do, but usually this is coupled with using PID host, so because you need to have access to a process that's running outside of a container, right? And then what can I do with ptrace? I can just debug that process, inject malicious C code inside of it, and let it run. What does that do? Whatever we want, right? So keep in mind, if you see this, or any other, whenever you see cap add, ask yourself, what does that stuff really do? Or why does this repo have only 5 stars, or something like that, right? Yeah. For those who were listening to me previous year, you know that previous year I was mostly just typing here and ignoring you. Now I'm mostly just talking to you and showing that. So, yeah, this is linked to the previous presentation of, yeah. And inside of that, you have all the commands to spawn containers, whatever, using just kernel API, if anyone's interested. I think also there's recording, yeah, so. And also linked vulnerabilities. So the next time now, because I showed you what, oh, okay, I'm not, because I told you what runc and stuff is, right? Next time you see a vulnerability, you actually know where the vulnerability comes from, right? Because, for example, there was a runc vulnerability that allowed a container to reference proc self-exe to overwrite basically the runc, because runc was calling it. And malicious guy could overwrite that that executable with its own executable. And next time the containerd ran runc, your binary was run, right? So imagine that. Or some vulnerabilities from actual containerd, right? So yeah, this is all. Hope it was not too boring. Thanks for listening. Any questions, let me know. If you're more interested in some certain like rootless containers or how networking works inside of the Docker, also you can talk to me. Thank you.